Okay, so this is from my home. Let's see how this works. Let's see if you can see the board. Let me know if it doesn't work. Today we're going to be talking about the quadratic formula. And before we do that, I just want to do. Can you see that? Yeah. Before I do that, I want to do a little review. So the first thing is about simplifying radicals. Simplifying radicals, and that's simply it's analogous to like reducing fractions. And so, for example, you might see radical 48. There's an expectation that at this point you've seen radicals. So the idea is, how do we simplify this? Well, we need some rules. We know that radical x times radical x equals x. We also know that radical a is times radical b equals radical a times b. So, how do I simplify a radical? Well, we take 48 and break it down to its prime factors. 2 goes to 24, 24 goes to 2 and 12, 12 goes to 2 and 6, and 6 goes to 2 and 3. Next, because the 48 was under a radical, put the primes under radicals. And then look for matches. Radical 2 times radical 2 is 2. Radical 2 times radical 2 is 2. Radical 3 is alone, it doesn't escape the radicals. Radical 3, final answer, 4 radical 3. This is how we simplify it. Let's try another one. How about radical 28? Well, we can break this into 2 and 14, 2 and 7. So again, put all the primes under radicals and look for pairs. Radical 2 times radical 2 is 2. Radical 7 doesn't. Let's try one last one. Radical 60. Radical 60 is, let's see, we have 2 and 30, 2 and 15, 3 and 5. Okay, well the 60 was under a radical. Can you see that? Yes. So that means we have to put all the primes under radicals. So 2 and 2 becomes 2, 3 and 5. There's no matches. They go back onto the radicals together. Radical 15. Okay. So, next, quadratic formula. So what we've been doing in this unit is we've been looking to find we've been looking how to draw a parabola, axis of symmetry, turning point, the y-intercept. We were also really interested in the x-intercepts, also known as the x-intercepts, or they were the zeros or the roots. And we found the x-intercepts when we set the quadratic equal to 0. Okay, so we are interested in finding the roots. And that's where ax squared plus bx plus c equals 0. And this was where the parabola crosses the x-axis. Now, you can find this using technology. You graph the parabola, and you go to math, and you do like trace, and you look for the zeros or the intercept with the x-axis. But either way, you can find it with the technology. But there's a formula that IB wants you to know, and that you should know. It's called the quadratic formula. So we can also use the quadratic formula. I call it QF. Okay, and the formula is basically this. Once again, write the equation, the quadratic in standard form, identify the A, the B, and the C, and then use the formula. And I'll sing the song for you. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Let me write that formula down for you. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So you now have all these choices. You have non-calculator and you have calculator choices. So if I give you the equation, if I give you something basic like x squared, let me turn the light on. I think it's a little, is it dark in here? doesn't really matter. If I give you the equation x squared plus 5x minus 14 equals 0, you might say, hey, Mr. Adler, I'm using the calculator. I'm just going to plot this parabola, or I'm going to use the algebra method to find the roots. You could say, so you can use the GEC, or you can look at this and say, you know what, Mr. Adler, I understand the whole factoring unit. I know that 14 is 7 and 2. I can get to the 5, so you can use factoring. Right? If you use factoring, it's x plus 7, x minus 2 equals 0, x equals negative 7, x equals 2. Or now, if you don't like factoring, you're like, Mr. Adler, I never learned the calculator and I don't know how to factor, you can use the quadratic formula. Quadratic formula, well, my a is 1, my b is 5, and my c is negative 14, and you simply plug these numbers into the graphing calculator. And so you have x equals negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 14 all over 2 times 1. Now, oh, I'm sorry, it was negative 14. I apologize. So let's see. These are, if you have to use the quadratic formula, you're going to get to use a calculator. But let's see. So we have negative 5 plus or minus the square root of 14 times 4 is 56, and 56 plus 25. Remember, because we're subtracting a negative, so it's 25 plus 56, that's 81 all over 2. So our final two answers are negative 5 plus 9 over 2, which is 4 divided by 2, which is 2, and negative 5 minus 9 over 2, which is negative 14 over 2, which is negative 7, and we saw these are our answers. So the quadratic formula is a much faster way of finding the roots. Now let's try some more. Let's try a couple more. Let's see. Some things you don't know. Yeah, let's try a couple of others. 2x squared minus 7x plus 3 equals 0. Well, maybe you didn't really learn. Can you see it? Maybe you didn't really see. Maybe you didn't really learn how to factor. So you'll try the quadratic formula. So let's see. A is 2, B is negative 7, and C is 3. And so we have x equals negative b. We're going to be negating the 7 plus or minus the square root of b squared minus 4ac all over 2 times 2. And this works out nicely. So we have 7 plus or minus the square root of 49 minus 24 is 25 all over 4. And so we have the two solutions, 7 plus 5 over 4, which equals 3, or 7 minus 5 over 4, which equals 1/2. We start to get fractional answers when we have non-monic quadratics. Okay. Let's try, I want to do 3 more. There's 3 more I want to cover. How about x squared minus 8x plus 4 equals 0. Now, I immediately know I can't factor this, but I know there's roots. How do I know there's roots? Well, if I graph this parabola, I know that it crosses the x-axis somewhere, right? It's over here. I know that there's roots. I know there's roots, I just don't know where they are. And that's what we're going to talk about a little after. So let's see what's going on here. X equals negative 8 plus or minus the square root of b squared minus 4ac all over 2a. Excuse me. So we have 8 plus or minus the square root of 64 minus 16 over 2, which is 8 plus or minus the square root of 48 over 2. Plus or minus. Now, the reason I did that radical thing is, if you said something like SAT2 or another, they might expect you to like simplify this. So you're looking at this, you're like, well, 48 is not a perfect square the way in the last two examples we got a nice number under that radical. That's okay, because we can deal with radicals. If you recall from the original lesson, the first thing I did, radical 48 was 4 radical 3. So we would write this as 8 over 2 plus or minus 4 radical 3 over 2. Final answer, 4 plus or minus 2 radical 3. This is it's not that it's a little advanced. It's tedious. You need to know how to manipulate this. You might be asked this like on an SAT or something like that, where like identify this expression. Okay, next problem we'll look at. Next, x squared plus 6x plus 9 equals 0. Let's use the quadratic formula here. So we have x equals negative 6 plus or minus the square root of 6 squared minus 4ac all over 2 times 1. And so we end up with negative 6 plus or minus the square root of 36 minus 36 of 0 over 2. And so we get two of the same answers. We get negative 3 and negative 3. Now that's odd. We know that it's a quadratic. It has 2 roots. But why are they the same? Let's take a look at the graph. If you can go to decimals or your graphing calculator and put this parabola in there, you'll notice that it looks something like this. This is interesting, right? In the other 2 examples, it looked like this, where it clearly passed through the x-axis. Over here, it kind of just touches it. The last example I want to go over is a case where we're not really talking about in our class, but in the case where it's a parabola and it doesn't cross the x-axis. That example is x squared plus 2x plus 8 equals 0. Now, you can go to your graphic calculator and look at this parabola and say, wait a minute, I know it's a parabola, Mr. Al. I know, I know it looks like this. And so the question is, if there's no x-intercepts, are there roots? Well, there are 2 answers because the quadratic formula says there's answers. So let's see what's going on here. X equals negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 8 over 2a. We end up with negative 2 plus or minus the square root of 4 minus 32 is negative 28 over 2. Now, for SL, this is outside the scope of our class, negative numbers under the radical. And what we see is, when we have negative numbers under the radical, we're not going to have any real roots. Now, that's the last thing we need to discuss. Because it's all about technology and, what do we need this for? You can just go to your graphing calculator and figure out the roots. Well, you're taking SL and you don't get to use a calculator for one paper. So what they do is they'll say, what are the nature of the roots? What are the nature of the roots? Now, we saw 3 examples. We saw parabolas that crossed it here. We saw some parabolas that kind of touched it here. And in the last example, we just saw parabolas that didn't even touch the x-axis. Now, what we're going to do is we're going to look at the discriminant. The discriminant. The discriminant is that expression under the radical. And if you recall, that was b squared minus 4ac. Sometimes it's referred to as a delta. Now, this is kind of cool. Think about this. If the expression under the radical is greater than 0, we have two non-equal real roots. Over here, in this example, the number under the radical was 0, and then we just had one root. It was a double root, and it just touched the x-axis. It's known as tangent to the x-axis. So if b squared minus 4ac equals 0, we have two equal real roots. And here we see the parabola. The parabola is tangent to the x-axis. And in the last example, we see that the discriminant over there was negative. So we see that if b squared minus 4ac is less than 0, we have non-real roots. And once again, non-real roots. Once again, the parabolas do not intersect the x-axis. This is outside of the scope of this class, complex numbers. You are going to be asked questions dealing with the nature of the roots. So what they're going to say is, here's a perfect example. They're going to give you a quadratic. They're going to give you a quadratic. They're going to say, given, 2x squared plus 3x minus k plus k equals 0, and they're going to say, find all values of k, where the roots are, real and not equal. And you have to remember that when it's real and not equal, you go, okay, b squared minus 4ac is greater than 0. You look at your ABC and you go, fine. 3 squared minus 4 times 2 times k is greater than 0. 9 minus 8k is greater than 0. Negative 8k is greater than negative 9. K is, remember, less than 9 over 8. Remembering that when we divide or multiply by a negative, we flip the inequality. And that's the idea. These are the type of problems. Either the roots are real and not equal, they're real or equal, they're a duplicate root, the parabola is tangent to the x-axis, or the last case, the roots are not real. Once again, if the discriminant is greater than 0, you have two non-equal real roots. If the discriminant is equal to 0, the two roots are equal. They might say the parabola is tangent. And in the last case, the discriminant is less than 0, we do not have real roots. The parabolas do not intersect the x-axis. Excellent.